Let's take a look at 1.6b. We're going to graph some other trig functions. So far we've graphed sine and cosine and tangent and cotangent. Now we're going to look at cosecant and secant. Now the nice thing about these is that these are the inverses of sine and cosine. So if you were good at graphing the sine and cosine, you should be pretty good going ahead and graphing these. Okay, so the sine is equal to x. Sine of x is equal to 0. So if I were to draw in let's say down here the sine graph. The sine graph would have a period from 0 to 2 pi, and I'd cross halfway, halfway, halfway. Sine graph goes up to 1, comes down to -1, goes up, comes back down, comes back up. Okay, so it looks something like this. Okay, that would be my sine graph. And so it crosses and it has, it's equal to x when x is equal to 0, when x is equal here at pi, and at the end of the period at 2 pi. Well, the cosecant is undefined because I have that sine value equal to a 0. When I flip that 0 over, I do the reciprocal, it becomes undefined, right? So if I have 0 over 1 and I flip that over to give me the cosecant, I get 1 divided by 0. Well, 1 divided by 0 is undefined. That's undefined. That's the definition there. Okay, and so it's going to be undefined at 0, pi, and 2 pi. Okay, and so when I draw in this sine graph, well, what I actually want to be doing is I want to be drawing in the sine graph kind of dashed, like it's a dashed line, because it's going to just give me a general idea of where my cosecant graph is going to go. And my cosecant graph is going to have asymptotes at those places that the sine graph has zeros, because it's going to be undefined. It's not going to exist in those places. And so then when I graph this cosecant graph, it actually has these same places on this sine graph. At the zeros, it's going to be undefined, and at the amplitudes, it's going to create this awesome little cosecant graph like this. Okay? So it's really the same idea. You're graphing a sine graph, so you graph the graph as if it's a sine graph, and then you just draw in the cosecants and the asymptotes. Okay, and so you go through, and that's really the way that you want to go about this. Okay, so in the second one, we're going to draw the cosine. So the cosine graph usually looks like this. It goes down, up 1, down to -1, starts at the top of the amplitude, ends out here at 2 pi, at the back at the top of the amplitude. About halfway through, it crosses pi, crosses here, and pi over 2, and at 3 pi over 2. These are all places that this is always crossed. This goes down here. But again, instead of me drawing this as a solid graph, I'm going to draw it in as a dashed graph, because this isn't the graph that I actually want to be drawing. And it's going to help me draw the secant graph, though. So the cosine is equal to 0 at pi over 2. It's equal to 0 at 3 pi over 2. Okay, and those are the two places in our normal period from 0 to 2 pi. Well, the secant, again, for the same exact reasons from the sine and cosecant, the secant is undefined at those exact same places. Okay, so that's pretty handy when I'm looking at this, because I can just draw in my cosine graph, and I can draw in some asymptotes when this crosses the x-axis, and then I can go ahead and draw in the graph at all of these different amplitudes. Okay, so that's actually going to be a period and a half of the secant graph, because the secant graph is going to have two places here that would two sets of asymptotes that it's going to fall between. So it's got one u that goes up and one u that goes down. Okay, and so again, if you know how to draw the cosine and sine graphs, the cosecant and secants are reciprocals of those, and so it comes out to really just end up being on the amplitudes of those two original graphs. So here's kind of an example, but I'm going to leave it in the notes section here, because it's really steps for graphing the secant and cosecant graphs. So you want to decide if it's sine or cosine. Okay, and then you want to graph that. So you're going to really be graphing the sine and cosine. So cosecant is like graphing sine. Okay, cosecant and sine go together. I want to find the zeros and the undefineds. Well, that means I actually have to go through and graph that sine graph. So when I graph the sine, I'm looking for the period, I'm looking for the amplitude, I'm looking for horizontal shifts, and I'm looking for vertical shifts. I'm looking for all that stuff still when I graph my sine and cosine. So in this particular case, I've got an amplitude of 1, and I've got a period of 2 pi divided by 1/3, which is 6 pi. So when I go to graph this, and I'm going to graph the sine graph of this, it doesn't have any horizontal shifts or vertical shifts. It starts there and ends here at 6 pi, halfway in between here at 3 pi, halfway in between and halfway in between. The sine graph, it's got an amplitude of 1 and -1. The sine graph goes up, comes back down, goes down, comes back up. Okay, so the first thing that I want to do is I want to draw in the sine graph. There's the sine graph. But I'm not graphing the sine graph, so I don't do a solid line. I do a dashed lines the whole way. So then I want to do zeros and undefineds. Those are asymptotes. Okay, so I'm going to put asymptotes at these zeros and undefineds. Okay, so here's zeros. That makes them undefined. So I'm going to draw in my asymptotes there. Then I'm going to actually draw in the parabolas at the minimums and maximums. Okay, I'm going to draw in the parabolas at the minimums and maximums. So here's a maximum. I'm going to draw in my parabola there. Here's my minimum. I'm going to draw in my parabola there. That's one period of the cosecant graph. Okay, now we're going to take a look at some examples in the next video, but this is essentially the idea. You're graphing sine and cosine. You want to draw in the zeros and undefined, which we call asymptotes, and then you want to put the parabolas at the minimum and maximums to get your cosecant graph here.